In past videos, we have seen the concept of dot products. There is another vector product which is called cross product. In coming few videos, we will know and learn more about cross product. But before we go there, we'll build certain concepts that will ultimately build to the definition of cross product. Okay, so let's talk about first concept. So if you have a parallelogram with a vector, b vector, then the area of this parallelogram with this angle is theta, right? Then we say the area of parallelogram is base into height, which is equal to area of parallelogram. Height is b sine theta, and therefore area of parallelogram is equals to a vector into b vector magnitude into sine theta. Now, how would you solve this? If this was cos theta, or we could have easily put as a dot product of a and b. However, this is sine theta. So one simple way is we find cos theta. We find cos theta as a dot b upon mod of a into mod of b, right? And then use a simple trigonometric formula, which is sine square theta plus cos square theta equals to 1, right? However, this seems a bit complex and need a lot of computations. Can there be a simple way to answer this question? Okay, so let's think about this. So if you have a vector A, if you have y and x, if this is vector A and this is vector B, if I draw a 90-degree, this angle is theta. If I draw this 90-degree, then this angle is 90 minus theta. This is A prime, such that mod of A prime, mod of A is equals to mod of A prime. So therefore, we can take this equation and we can write it equals to, so we can replace A as mod of A prime into B vector into sine theta. Sine theta is equivalent to cos of 90 minus theta. And let's call this as theta prime. So this is A prime dot B prime dot B into cos theta prime, right? Which is equals to A vector prime dot product B vector, right? So if I can compute A prime, and I already know B vector, so if I can compute A prime vector, then I can solve this equation and represents what an area of parallelogram is. So let's see how to solve this. Okay, so if you have x and y, and if you have a vector a given by coordinate a1 and a2, that is a1 I cap plus a2 j cap, then you put an angle 90 degree, which is a prime. Then how would you find a prime? Right? So one simple question, let a prime be x1 I cap plus y1 j cap. We know that a vector is equals to a1 I cap plus a2 j cap. A prime dot a is equals to 0 as theta is equals to 90 degree, right? And therefore x1 a1 plus y1 a2 is equals to 0. Also mod of a prime is equals to mod of a. This implies x1 square plus y1 square is equals to a1 square plus a2 square. If you solve equation 1 and equation 2, this will imply x1 equals to minus a2 and y1 equals to a1, and therefore a vector prime is equals to minus a2 I cap plus a1 j cap. So let's go back to the formula. So what we were solving is area of parallelogram, which is a dot b dot sine theta, and we proved that if I have an angle a prime which is 90 degree, then this is equals to a prime dot product b prime. Now if b vector is equals to b1 I cap plus b2 j cap and a vector equals to a1 I cap plus a2 j cap, then we just saw that a prime is equals to minus a2 I cap plus a1 j cap. We just proved this, and therefore area of parallelogram is equals to this vector dot product with this vector. Right? So what does that mean? So this means minus a2b1 plus b2a1. That is, let's rearrange this, a1 b2 minus a2 b1. This is an area of parallelogram. There's a special name to this quantity which we call as determinant. And determinant is defined with this symbol a1 e2 b1 b2, which then is solved as cross multiplication a1 b2 For the second term, we add minus a to b. So basically, area of parallelogram. So basically, area of parallelogram is given by a determinant of vector A and vector B. Okay. However, note one thing. There is no guarantee of the sign. Depending on which number is bigger, we can get either plus or minus, right? So area of parallelogram is therefore mod of, which is absolute value of determinant of A vector and B vector. So the area of parallelogram is absolute value of the determinant A vector and B vector. Right. Important concepts. Do remember how the determinant is calculated in two-dimensional space, and that determinant represents the area of this parallelogram. In the next video, we would take these concepts into three-dimensional space, and then subsequently we will move to define the definition of a cross product. Great.